Hi, today we're going to extend our conversation of dimensional analysis by talking about derived units. What is a derived unit? Basically, it's a unit that's created by putting together one or more of what we call the fundamental units. For example, let's take the meter. We know that we can use the meter to measure length. Well, we can also use it to measure other things that are not length, like area. So if you have a dance floor that you need to cover with some sort of flooring material, you want to know how big the floor is so you know how much to buy. The way that we have been taught to calculate this is just to take the measurements of the length and the width, 11 meters and 5 meters in this case, and multiply them. Okay, so if someone asks you how big is the floor, what you're going to do is you're going to multiply those two measurements, 5 meters times 11 meters, and that turns out to be 55 square meters. Now, what does square meters mean? If you think about the units, you're measuring meters times meters, and meters times meters is meters squared. So that's one way you can think about it. You can think about it from a purely unit perspective. But let's think about this another way. You're going to do this flooring with enormous floor tiles that are each 1 meter by 1 meter, so 1 square meter. So when you go down to Lowe's or whatever, how many floor tiles do you have to buy in order to cover the entire floor? So you can think about taking these 1 meter by 1 meter tiles, and how many are you going to have to put down in order to cover the whole long side of the floor? And the answer is 11, right? Because each of them is 1 meter wide and the floor is 11 meters wide. Well, that's just one row. How many do you have to put down in order to cover the entire floor? Well, you're going to need more than one row, right? How many rows will you need? You'll need 1, 2, 3, 4, 5 rows. Does this make sense? Yes, it does, because each of those rows is 1 meter wide and you need to cover a 5 meter area. So that's a different way you can think about measuring area. And in either case, we end up with this unit that is a derived unit that is a square meter, that is derived from the fundamental unit of 1 meter, which is our distance measurement. Let's carry this a bit further. Rather than talking about area, let's now talk about volume. So the official unit of volume is a meter cubed. So that's something that's 1 meter by 1 meter by 1 meter. And at some point in your lab, you're going to get out your measuring tape and you're going to see exactly how big a meter cubed is. It's pretty enormous. So we almost never used meters cubed in chemistry. What we're going to use is decimeters cubed, which we call 1 liter, and centimeters cubed, 1 milliliter. So let's ask ourselves now, how many decimeters cubed are there in a meter cubed? So how can we think about this? Well, let's just imagine taking little cubes that are 1 decimeter on each side and seeing how many we can fit inside our big cube that is a meter cubed in volume. We know that there's 10 decimeters in a meter, so as we stack in our little cubes that are each 1 decimeter on a side, what we're going to find is that there will be exactly 10 in one row along the edge of the cube. How many rows of those 10 cubes would it take to fill the bottom of the box? You can just imagine that since the meter cubed is exactly 1 meter wide and each of those rows is 1 decimeter in width, well, you're going to need 10 of them. So again, that's 10. Now that fills up the entire bottom of the cube, but what we want to know is how many little cubes it'll take to fill up the entire cube. So now we're going to have to start stacking these layers. And so you can just imagine how many of those square layers of cubes will it take to fill the entire meter cubed. And so you can start stacking them, and it's going to get really messy if I keep doing that. So let's just kind of think through it. This large box is 1 meter high. Each of our layers is 1 decimeter high. How many decimeters is it going to take to get 1 meter high? It's going to take 10. So we have a row of 10 cubes. We have 10 rows, 10 cubes each, making a layer of 100 cubes. We have 10 layers of 100 cubes each. So one way we could put this is 10 decimeters along one length of the cube times 10 decimeters wide times 10 decimeters high will give us 1,000 decimeters cubed. So there are 1,000 cubic decimeters, the same as 1,000 liters, in 1 cubic meter. So let's now talk about a different derived unit, which is a little more complex, and that is density. So what I want you to do here is think about this site, which is so common in current culture, the Amazon box. You come home, you see a package sitting in front of your door, and you're like, hey, my textbooks are here, woohoo, because you've just ordered 3 really large, unfortunately expensive textbooks from Amazon. So you go up to the step and you brace yourself as you pick up the box, and it pretty much goes flying up because it's so much lighter than what you expected. And when you open it, no wonder, it's just full of those air pillows. You'd forgotten you'd ordered some random trivial little thing. This Amazon box of fixed volume can contain a lot of mass, or it can contain a little bit of mass. The volume of an object does not tell you how much it weighs. So how much mass is in a given volume? That's what density tells us. And so the way we define density is mass divided by volume. Well, what are the units on that? The units of mass are kilograms, and the units of volume are meters cubed if you're talking about the SI system of measurement. But like I said, a cubic meter is a huge box. I don't think I've ever seen an Amazon box that big. So a lot of times in chemistry and other environments, we talk about grams per cubic centimeter. And that's what you're going to be seeing a lot of. Now, one thing I want to point out, in some places, including some parts of your book, they're not going to write this unit as a fraction of grams divided by centimeters cubed. What they're going to write it as is grams times centimeters to the minus 3 power. So what is the minus 3 power? It's just something cubed and then 1 over that, the inverse of centimeters cubed. And so those mean the same thing. You'll see these units with negative exponents all throughout science, including in the scientific literature. So it's really important to understand what those mean. The last thing you're going to be seeing a lot of in chemistry is a joule, which is a kilogram meter squared per second squared. And again, I've written that in the alternative format, the way that you will often see it in scientific literature, kilogram meter squared seconds to the minus 2. So what we're going to do now is we're going to work a dimensional analysis problem using derived units. And the question we want to start with is this: how many square meters are in an acre? So in the United States, if you buy a plot of land, you're going to get measurements in either square feet if you have a really small parcel of land, or acres if you have a reasonably sized parcel of land. But everywhere else in the world, and especially in science, is going to use square meters. So it's important to know, if you're doing a field study, for example, out in the forest, to be able to convert your acreage into square meters. As usual, we're going to go through our 4 steps, identify the units you want to know, how many square meters, so that's the units we want to know, and we're going to write that as meters squared. The next thing we want to know is what units do we already know? Now, normally when we do this step, we look for things that we have a number associated with, and this just says an acre. Well, that's just 1 acre, right? So 1 acre. And then we have to find our conversion factors. And the annoying thing about this problem is that you can't always find the conversion factor that you want. So what we're going to do here is we're going to set this up with a whole bunch of conversion factors that we have. 1 acre is 43,560 square feet. I know that's a weird number. It comes from these really weird units that surveyors used to measure that you'll learn about if you ever go into forestry. So let's do that. That will convert our acres into square feet. Well, I don't know how many square feet there are in a square meter, but I do know how many inches there are in a foot. So I'm going to put that in. That'll give us inches. And how many inches there are in a centimeter, I know that. So I'm going to put in that conversion factor. And now I'm going to put in how many centimeters in a meter. But that is not going to give us the units that we need, because what these are telling us is how many inches in a foot, but not how many inches there are in a square foot. So what I'm going to do right now is I'm going to go through and square this. I'm going to square that. I'm going to square that. And I'll show you why in a little bit when we check our units. So if you do the math, you come up with 4,046.9 square meters in an acre. Okay, so let's check our units. So what we're going to do first before we check our units is let's look at this thing right here, which is 12 inches divided by 1 foot, quantity squared, and let's square everything within those brackets. Okay, that will give us 144 square inches. That's 12 inches squared, divided by 1 square foot, which is 1 foot, quantity squared. Okay, then we can go through and do the same thing with this. Let's square that thing, and we get 6.4516 square centimeters per square inch. And then let's square this. That'll give us 1 square meter divided by 10,000 square centimeters. And then let's go ahead and throw in the stuff that we aren't changing right here, and let's check our units. So here we have acres converting away, we have square feet converting away, we have square inches converting away, and we have square centimeters converting away. And the only thing that's not converted away is square meters, which is what we want. So that was set up correctly. So again, here we're looking at how dimensional analysis can help us solve problems. And I showed you a unit conversion, but this is useful for a lot of different problems, as we see when we'll start getting into energy and stuff like that. We use a lot of these derived units in chemistry, so it's very important that you know how to use dimensional analysis on them. I hope this was helpful, and I look forward to seeing you again soon.